Hi guys, it's Dr. Atchison here. Bear with me, I kind of truncated the slides a little bit and really focused in on what you really need for your exam on Thursday. If at any point during the lecture I don't make any sense, just chalk it up to my congested brain. Refer either to Launchpad, your textbook, or email me for clarification. I will do my best. Thank you for bearing with me. So again, we're continuing on chapter 8, talking about memory. So this is where we left off, talking about HM. I feel like any intro psych class has to talk about HM. It's a obligatory kind of thing. So HM suffered from epileptic seizures, and at 27, they removed part of his brain to prevent these seizures. What happened in the process is that his hippocampus was damaged. He had explicit memories. Remember, those explicit memories are things remembering how, remembering information about something. So you know that, as you know the definition of memory, things like that. That would be an explicit memory. However, he could not create new explicit memories after the surgery. He could recognize himself in pictures before the time of the surgery, but he could not later recognize himself. He lost explicit memory for events that happened after the surgery. So again, he could not form these new explicit memories. We're not talking about implicit information. He retained those implicit things. He performed normally on these kinds of procedural memory and priming tasks. Anything that he had learned before 27 was retained, and anything that was an implicit memory task that he learned after the surgery, he was able to learn new implicit memories. He just wasn't able to make new explicit memories. Again, this suggests that those explicit memories are really processed by the hippocampus, that the hippocampus is playing a vital role in this creation of these explicit memories, the knowing that, the knowing a fact, those kinds of things, knowing about something, that those memories are being really formed in some way, or their formation is highly impacted by the hippocampus. Whereas implicit memories, because again they were unaffected in HM, are processed somewhere else in the brain. HM is a really good example of how we use brain lesion studies to learn about the brain and learn about different parts of different things that the areas of the brain do. We learned a lot about memory, implicit and explicit memories, and where they're processed in the brain through this study of HM. Again, this lesion was not done on purpose as a way to study memory. He had really bad seizures, and as a treatment, they performed this lesion surgery as a treatment for these seizures. This was the byproduct or the side effects of this surgery. So a lot has been learned about the processing because of this kind of byproduct, this accidental science. So next, let's go in and talk about different kinds of ways we can get memory out of long-term memory. So getting out information, we can do that again through recall. And this is bringing that previously learned information into the conscious awareness. This is going to be more of those fill-in-the-blank questions on the tests. This is going to be this in Bloom's taxonomy, this remembering. Bloom's taxonomy is not included in your textbook in this area. I include it because we're talking about how these kinds of memories related to tests. Remembering, you see, is kind of the bottom level of learning. Bloom's taxonomy is about learning. And you can see it's kind of the most basic kind of learning is if you're able to remember something. So recall and recognition. Recognition would be even lower than recall, and that's going to be on such as like a multiple choice question, something like that. And again, that's all happening at this bottom level. When we're talking about studying for your tests, I really want you to be more at the understanding, applying, analyzing kind of level. So again, when I give you a situation and on a test question and ask you to apply that knowledge, what is that? What does that look like? It's not just a definition. We're in that purple vein, that applying. And again, these higher forms of learning are more beneficial to you in the long term. So context effects, we talked about them a little bit. I alluded to them last week. And this is that ability to recall information is improved when we're in that same context that we learned it in. So again, taking your test in the room that you learned the material is very beneficial. There's been some really interesting studies that looked into this. So in an experiment, scuba divers listened to words on land and underwater. And so they listened to these, they learned these words in various contexts. And so they had different groups of people. Some scuba divers learned the words in the water, some scuba divers learned them on the land. Then afterwards they were asked to recall these words, and they were either, the context was matched, so if they learned them on land, were asked about them on the water, or on land. If they learned about them in the water, they were asked about them in the water. Or the context didn't match. They learned about them on the water, and they were asked about them on the land. They learned about them on the land and were asked about them underwater. So again, the context, they were either in these context match, which are these kind of more long left side of the graph, versus the context didn't match. And what they found is that words heard underwater were better recalled when underwater. Words heard on land were better recalled on land. Context made a difference. They did a good job in remembering those words when the context that they learned them in was the same as they were tested in. However, when those contexts didn't match, we saw a big decrease in the amount of percentage of words that were remembered. So again, the context is playing a role in memory. Context can provide cues for us that allow us to remember where we were when we learned them, and those cues can again help us retrieve the information out of long-term memory into working memory. So the context effect says that we also talks about state-dependent memory. So the state you were in, either the emotional or the biological state, can also be a context cue for that memory. So we find in studies that it's difficult to remember happy times when one is depressed because there's a state that doesn't match. If you're in the depressed state, it doesn't match the mood you were in when this happy event occurred. And again, it may also explain why after a happy experience that people are kind of viewing the world more optimistically because they're in this state of happiness, optimism, and again, it's going to rose color, their future memories. So let's move on to forgetting. Hopefully I'm not forgetting anything here in context before we move on. And again, thank you for bearing with me. This clearly will not be my best online lecture ever. Probably one of my worst. So I apologize. But again, I hope this gives you a little bit of a boost in terms of this information over what just your book would provide. So there's a lot of different reasons that we can forget things, one of which is encoding failure. Remember, encoding is when we put that information into memory when we're trying to remember something, and that can either happen in this really automatic way, which implicit memories, or can happen in an effortful way with things like explicit memories. So in an encoding failure, you may forget something because the information never got encoded correctly into long-term memory. It was never encoded. If it was never encoded, you can't remember. So if it never reached long-term memory, you're not going to be able to retrieve it from long-term memory. So that would be a reason you forgot something, was encoding failure. It wasn't encoded properly. It was never properly put into long-term memory. Another reason may be storage decay, and this is memories decay gradually if they're not used. When you remember something and you think about it routinely, every time you think about that memory, you're strengthening that memory. You're thinking about it, you're brushing off the dust, you're strengthening that memory, you're using that memory. When you don't use a memory, these memories start to decay and they start to lose their richness. This happens really rapidly at first, but after a certain time period, it starts to level off, and it's no longer that rapid decline. Again, these memories can continue to persist really long term when we use them frequently, and then storage decay doesn't happen. So storage decay is happening from memories that we're not using frequently. And so again, over a period of time, they're just, because it was not used, something else has taken over. I know when I talk about things that I learned as an undergraduate, I'll say that neuron is being used for something else now. It's been replaced with something else. Now, clearly that's not biologically what's happening, but the idea was I wasn't using it, so I lost it, and I've replaced it with something new. Another reason that we can have problems with forgetfulness or forgetting is retrieval failure. One of these types of retrieval failure is called the tip of the tongue phenomenon. This is when you remember something and it's right there on the tip of your tongue, but you really can't get it out. We've all experienced this. And this is that information's there, but maybe the context and the cues aren't sufficient to pull it out. Again, you know it, you can see kind of things around it, but you really can't pinpoint that exact thing that you're trying to talk about. Another kind of retrieval failure is interference. There's two kinds of these we'll talk about, and I've got another slide that shows you a picture of this, one of which is proactive. Proactive is the disruptive effect of learning something previously on the recall of new information. So you know something already, you're trying to encode this new information, and what you know already is messing with the new information you're trying to recall. So that's the proactive kind of interference. Retroactive interference is the disruptive effect on new information. You're learning something new, and the learning of this new information is impairing your ability to remember old information. So again, these are two different ways that memories can interfere with each other, that new information can interfere with old information, or old information can interfere with new information. And again, these are happening kind of in opposite directions, and the next slide will really show you that. Another problem that we have in retrieval failure is motivated forgetting. Freud talked about this in terms of repression. He said it's this defense mechanism that banishes these anxiety-riddled memories from our consciousness. The idea is that this preserves self-concept, and it preserves our idea of ourselves without this anxiety-causing kind of memory. Freud would also say that this memory can be retrieved through various cues or therapy, but as we learn more and more and more about the brain and memories and psychological kind of disturbances that you would see in something like a Freudian therapy session, that we find that repression really does not really probably exist. Again, most memory researchers don't find any support for this, and if they do have support, it's very, very rare. So this is not something that's happening on a large scale. This is not something that's happening very frequently. So once again, something that Freud did not get quite right, or maybe not right at all, so that this motivated forgetting, this repression, isn't something that's really going on. So here's that promised slide about retroactive and proactive interference. So in retroactive interference, again, the new interferes with the old memory. So you learn A, you learn B. Learning of B, the new thing, interferes with your ability to remember A. This causes memory loss for A. Again, this new information kind of supersedes or suppresses that information for A. So again, it's retroactive, and that the new information is retroactively forgetting the old information. Whereas proactive interference is happening, the old information is interfering with the new information. So maybe there's something that you know so well that anytime you try and remember something else, the new piece of information, you'll have problems. My parents are planning on moving soon, and one of the things that I'm from my childhood home, the house that I grew up in, and one of the things I'm most concerned about is their phone number. My mom, when I was little, it was the first phone number I had, and so I was taught a song about this phone number, and I know I will never ever forget their home phone number. So when they move to the new house and they're going to have a new phone number, I can already foresee having this problem with proactive interference, where I'm going to have a hard time remembering this new phone number that they're having, because I remember their old phone number so well. It's so ingrained in my memory. This song was so catchy that I taught it to friends in high school so that they could remember my home phone number. And to this day, they still say, "I will never forget your parents' phone number." That song, it's stuck in my head. So again, this old information can interfere with these new memories. We're going to skip this. I thought I had deleted those slides, so I apologize. Maybe I just deleted the next ones. So let me just push through that. Okay, so imperfect memories. I talked about this a little bit on Tuesday as well. We think we have really good memories, and we're really, really wrong. Part of the reason of that is we have this constructive nature of memory. In this in-class experiment I was going to show you, I was going to read you lists of words that all kind of circled around a general theme. One was kind of circling around the word chair, one was circling around the word girl, and what you find when you do this task is that most people say they remember hearing the word girl or the word chair, even though those words were never mentioned. But because all the other words are kind of circling around this central idea, your brain constructs this memory of it. So again, memories are very, very malleable. They're very, very influenced by our context and our surroundings and the information that's coming in. And again, we have a lot of top-down processing happening where what we already know is influencing what we're paying attention to. So what we already know about all these words, this central idea of girl or this central idea of chair, can cause us to create this memory for that. Again, this top-down processing will affect our storage and retrieval because it's highly influenced by our experiences and our expectations. And again, this is happening from that top-down. This is not happening bottom-up, where we're looking at all the different features of what's happening and constructing a memory. This is more top-down because we're expecting these sorts of things because of previous experiences. Those are the kinds of things that we're going to be attending to. And that's going to influence what we remember. And it's going to also how we can encode that, what we store, and also what we can actually pull out of long-term memory, what we can actually retrieve. These two problems of constructive memory and the malleability of memory is a problem in eyewitness memory and eyewitness testimony. There's a lot of research out there that eyewitness testimony is really not that great and can really not be the be-all and end-all, and definitely not to send somebody to prison for a very long time. We see a lot of cases being overturned that were founded on eyewitness testimony, and then DNA has since exonerated those people because DNA is not really going to be lying, whereas eyewitness memory, again, these individuals are not lying. They actually believe this is what happened, but because the memory is so malleable, because it's so constructive, because it's so influenced by these top-down processing, it can be very Swiss cheese-like and have a lot of holes in it. And a lot of times we will fill in those holes with what we expect and what we think people want to hear. The group of people that is most impacted by this is children. How we question them very, very much changes what they remember and what they say. This can be very, very adaptive. There's ways that we can help children kind of form these autobiographical memories by elaboration. So they're telling us something that happened and we were there with them, and we can fill in the blanks for them and help them really form these good memories. But in the case of something like a testimony, this can obviously have a lot of negative consequences. Information can be pushed one direction or another because of the influence of questioning in that. One of the ways that we see memories are imperfect is the misinformation effect. And this is incorporating misleading information into the memory of an event. So Elizabeth Loftus did a study where she asked two groups of people two different questions. She said, how fast were the cars going when they hit each other? Or she asked, how fast were the cars going when they smashed into each other? The second question has a lot more connotation on it. It's a kind of a more of a leading question. When you say something smashed into each other versus then they hit each other, it tells you that it's a bigger hit, right? That it's a bigger crash. And so you already have more kind of imagery attached to the word smash than you do to the words hit. What she found matches that idea. They reported the recall rate of the speed dependent on how the questions were asked. So if they were asked if they hit, they recalled the speed lower than if they asked that they were smashed. They depicted the events differently as well. So when they asked them if they were hit, the images would look more like this. This is what they actually saw, the depiction of the actual accident. But when they asked how fast were they going when they're being smashed into them, the people recalled the first image, the depiction of the actual event, more like the second image where it's got all this smashed glass and parts on the ground, because that information of smashed creates this bigger connotation of the accident. So again, just by asking questions different ways, by changing that one word, that leading question, changed the memory of the event that they watched. Again, they would have seen this as a video or just an image, and then were later asked to recall information about it. And when they later recalled this information, they saw that there was more. They remembered seeing more glass. They remembered these cars going faster than they actually did. And again, all of that was due to the word smashed. When individuals didn't hear that word smashed, where they only heard hit, they didn't remember the accident as being as dramatic. We can also have false memories. I assigned you for participation today a video activity on Launchpad. It is how researchers created false memories in college students, and kind of how it happened, how people responded, how malleable, again, memory is. So again, please watch that video on Launchpad and answer the questions for your participation points for today. So false memories are any memories that are planted. Again, these are not true memories. These are not things that people actually happened, but are being planted. And it's, again, this imagining of a non-existent event that creates a memory. Again, in the video that you'll watch, or may have already watched, I know a couple of you had seen it already, I checked, they were talking about hot air balloons, and they're able, and creating this false memory of going on a hot air balloon. Imaginary inflation is imagining something and perceiving it, and it activates similar brain areas. So again, imagining something that happened and actually seeing it, just like those mirror neurons were activating similar similar areas, imagining something happened and actually being there is doing the same thing. This can really, again, create these memories that seem really vivid and seem really real, but that are really coming out of imagination instead of an actual event. So again, these people with vivid imaginations are a lot more likely to have these false memories, because again, they are imagining these things. They are imagining these things are happening. When you have that really rich imagination where you see these things and you're experiencing them, they can seem very, very real. And again, they're activating similar brain areas. And so the pattern of brain behavior is similar. And so it's hard for the brain to tell what was imagination and what is a true memory. Children are very, very susceptible to these false memories because imagination is such an important part of their development and of their life. A lot of times children will really remember things that did not happen, that happened in imagination or those sorts of things, and they can get quite dramatic in pressing their case. So again, go in and watch that video on false memories. It's very, very interesting and very, very helpful for you. There's also two more things I assigned to Launchpad. learning curve assignments. And again, I think those will help you with this material that we would have covered today. I've given you kind of the highlight tour. There's one more slide I want to show you, but go do those other ones. Only the video memory will have participation points assigned. So again, the biological basis of memory, a lot of the cerebral structures are happening. Again, we talked about how not just one part of the brain is influenced by memory, but many, many parts. We know that the hippocampus is really, really important with explicit memory, as we saw with HM, and there's also several animal model studies where we can get rid of the hippocampus in animals, and we see really bad changes in their ability to form new memories. Lots of parts of the cortex are happening, and the cerebellum is also involved. Brain chemistry is also playing a part. Serotonin and acetylcholine are again different neurotransmitters, and these we find are very, very important to memory as well. So that's all the slides I have for you today. Again, I kind of cut them down to kind of minimize my lecture time, since clearly this was not easy on any of us. So again, thank you for being patient with your sick instructor. The test is still on Thursday. I will bring Scantrons. You bring pencils, and make sure you know your ID number. We will see you on Thursday. And again, if you have any questions, feel free to email me. That email is on the syllabus. Thanks so much.